Hello everybody, welcome to this course, Machine Learning for Absolute Beginners, an introductory course by Edionics. My name is Brendan Crabb. I'm going to be with you for the entirety of this course, and I can't wait to teach you guys a little bit about one of my passions, and that is machine learning. So let's go ahead and get started and dive right in. Unit 1, we're just going to cover a broad introduction to machine learning. So this is going to be a 4-video series if all goes according to plan. The first being this one, just what is machine learning? Hopefully we can answer this question by the end of this presentation. Video 2 is going to be on the types and applications of machine learning. So in this video we're going to dive into actual use case examples of machine learning in today's society and cover all the different types of algorithms that there are and how they're being used. Number 3, we're going to address artificial intelligence versus machine learning. There's a lot of misconceptions in this area that I think should be addressed early on. So we're going to understand a little bit more about AI and how it differs from machine learning and where it overlaps. Number 4, we're going to talk about the essential mathematics for machine learning and AI. There are several core competencies that you're going to have to know going in if you want to get the most out of machine learning. And so those include topics like linear algebra and multivariate calculus, but we will cover that more in depth in the fourth video. So let's get started. Let's talk about machine learning. So what is machine learning? This is the question that this video is going to cover. Let's try to address that now. So I want to start with this comic that I think does a good job of portraying the current state of understanding of machine learning. So this is the Dilbert Daily strip by Scott Adams. And in this strip, we have an individual who is interacting with a computer, doesn't know quite what it's doing, and as a result, the term machine learning is applied to it. There's plenty of sci-fi movies out there that have claimed that AI and machine learning algorithms are going to try to kill us. But that isn't actually the case, so let's hopefully clear up some of those misconceptions so that we don't have to just use the buzzword machine learning whenever we don't understand what our computer is doing. So what we lack in knowledge, we make up for in data. And this is at the core of what machine learning is. So machine learning is simply inferring knowledge from data. And then the learning step is when we're optimizing a performance criterion. So the machine learning is simply programming computers to optimize a performance criterion using example data or past experience. We have a model defined up to some parameters, and learning is going to be the execution of a computer program to optimize the parameters of the model using the training data or past experience. So that's the gist of it. At the core, it is inferring knowledge from data, gathering knowledge from data, however you want to say it, and then optimizing the parameters so that we can get better and better at whatever we are trying to do. So let's keep going. There are a couple main types of machine learning models that can be differentiated. So the first is predictive. About half the models are going to be predictive in that they are trying to make predictions on the future. So an example of this might be to predict whether a patient hospitalized due to a heart attack will have a second heart attack. So that would be an application in the healthcare field. The prediction in this case would be based on demographic, diet, and clinical measurements for that patient. Another example might be to predict the price of a stock in 6 months from now. We'd all like to do that. That could make quite a bit of money. And we would do that on the basis of company performance measures and other economic data. Another example would be to maybe estimate the amount of glucose in the blood of a diabetic person from an infrared absorption spectrum of that person's blood. And that would be another very beneficial use case scenario in the healthcare field. So the second class of machine learning models that we'll talk about are descriptive models. And these are simply trying to gain knowledge from data. And so this sounds more like our general definition of machine learning that we just gave in the previous slide. However, in descriptive models, the difference is that we're not going to have an expected output necessarily. So we only have input data to give it, and we're going to try to gather knowledge from that data. So an example of this would be basket analysis, such as learning associations. So in a supermarket, you could try to find associations between products bought by customers in that market, because that would be very valuable for the store to know, because then they could advertise and market towards those customers more effectively. Another one would be to potentially identify the risk factors for prostate cancer based on clinical and demographic variables. So we don't necessarily know what the output's going to look like, but we're going to try to gather that knowledge by analyzing this data. Okay, so these two types of learning can really be broken down into supervised learning and unsupervised learning. Again, in predictive, supervised learning is when we have examples of input data and output data. So in the stock example, we would have previous history of the input, such as economic data and company performance measures, and then how that stock performed over the next couple of months. And we'd use that input and output data to make predictions on the future. In the descriptive type of learning, which is unsupervised learning, we only have the input data and we don't necessarily know what the output's going to look like. And so that differs there. There is a third, and reinforcement learning can sometimes fall under unsupervised learning, but it in general is called semi-unsupervised. But for now, just knowing these two types of learning is going to be more than enough. And we are going to actually devote the entirety of Unit 2 into supervised learning and the entirety of Unit 3 into unsupervised learning. So we will get a much better understanding of what these algorithms are doing in those units. In the second video in this series, we're also going to dive into supervised and unsupervised learning a little bit more and give you some specifics on the type of algorithms that encompass both types of learning. So again, and I mentioned reinforcement learning, that sometimes falls under semi-supervised learning. It's kind of a gray area. We don't necessarily have output data, but we're teaching it in much the same way we would a predictive algorithm. But we'll talk more about that later. So I also want to talk about machine learning as statistical learning. Sometimes these are differentiated, but it's really the same thing. Machine learning is based on the theory of statistics and is built on math because the core task is making inference from a sample. This is exactly what statistics tries to do when you get into things such as probability theory. So a machine learning algorithm is based on statistical properties, and as a result, it doesn't really understand necessarily what it's doing, but it's going to try to make approximations or generate an output based on statistical probabilities. So that's a core essential concept of machine learning that needs to be understood, that this is all based in statistics. As a result, when we get to video 4 and we talk about the core math competencies, statistics and probability theory is definitely going to be on that list. All right, and so here's a quick term comparison so that we can kind of understand where the overlaps are, because you'll hear both sides of these terms being thrown around, and it can kind of get confusing if we don't differentiate them early. So in machine learning, we have networks and graphs, or algorithms. You might hear a machine learning network or a machine learning algorithm. And this, in statistics, is simply a model. So it's something that we're trying to use to model a different scenario. And then we have parameters, which in machine learning are going to be called weights. So when we said machine learning is using a computer program to optimize a performance criterion, where we're optimizing those parameters, these are the weights that we're going to be adjusting in machine learning. And then that learning phase in statistics would be called like fitting, like curve fitting, and it's going to be used in much the same way. And here we have supervised learning, unsupervised learning. In statistics, these are formally called regression classification for supervised learning. Classification being when you have a qualitative output, when regression when you have a quantitative output. So the difference is numerical or class. And then in unsupervised learning, we have things like density estimation and clustering algorithms. You might have heard of k-means clustering, and we'll talk a lot more about those specific clustering algorithms later. But for now, I want you to pay attention to the Google Research blog. Something that I want to do in all of these videos is provide you with a current article that highlights some cool things that are going on in machine learning today. So if you haven't checked out the Google Research blog, you should definitely do so. This is a great article on how a deep learning algorithm is being used to assist pathologists in detecting breast cancer. Very cool application of machine learning, worth the read. And again, if you haven't heard of Google Research blog, spend some time on there because they have a lot of good information on machine learning. Google has all of the data. As a result, they are one of the leaders in machine learning research. So it's always good to pay attention to what they are doing. All right, and so that concludes this first video. What is machine learning? I appreciate all you guys listening, and I look to have you guys back for video 2, where we'll talk about the types and applications of machine learning. Thanks for listening.